Hello everyone. In this video, I'll be solving uh, previous year questions of CUET UG. Okay, CUET exam will be held in mid-May, I think. So for that, you need to solve the previous year questions so that you can have an idea that what questions are coming in the exam. Okay. So I hope because most of you would have given the board exams recently, so I hope you would have remembered most of the concepts, right? So I won't be doing chapter wise because that is whole different. So we'll be solving the previous year questions. Okay, so let's do it. So this is the first question. Two charge particles placed at distance d apart in vacuum. Okay, exert a force F on each other. Now each of the charges is doubled. To keep the force unchanged, the distance between the charges should be changed too. Okay, so there are two charge particles, Q1 and Q2. Okay, with the distance d in vacuum. So the most important thing is you have 60 minutes only. Okay, and you have 50 questions. Number of questions to be solved is 40. So we have to solve 40 questions in 1 hour. Right, so we have to do it first. But anyway, I'll be explaining you. That's why it will take more time. Okay, so Q1, Q2. Okay, distance is d, right? So they exert a force F on each other. So which law? This is Coulomb's law, right? Coulombic force, which is F is equal to K Q1 Q2 by d square, right? Now each of the charges is doubled. So what will happen? I have to double each of the charges. So F is equal to K into 2 Q1 into 2 Q2 by d square, right? Suppose this is d1 square or d dash square because the distance is asked here. To keep the force unchanged, the distance between the charges should be changed. Okay, keep the force, and this means force should be equal in both the cases, right? So what can we do to get the distance? We can just equate them because the force is equal. So k q1 q2 by d square is equal to k 2 q1 q2 is 4 q1 q2, okay, by d1 square. We need to find out d1, right? So q1 q2 q1 q2 cancel, k cancelled out. So d square is equal to 1 by d square is equal to 4 by d1 square, correct? So d1 square will be how much? D1 square will be equal to 4d square. So d1 will be 2d. Okay, yeah. So the thing is, this is a very easy question. So we have to. The thing about entrance exams is we have to know time management. Okay, so you have to be aware that which question should take how long. Because this is an easy question, very easy question. This should not take more than 30 seconds. Even 30 seconds is actually, I'm saying more. Okay, so this question should take 30 seconds. So along with solving the questions, I will also tell you that which question should take how long. Okay, so yeah, so this answer is 2d. Okay, question number 2. So question number 1 is over. Now, question number 2, let's move forward to question number 2. So to parallel, another thing about entrance exams is if you realize that this question is out of your range, just leave it. Okay, I will also do it here, but no, I have to solve it everything, but like, I will just show you two parallel plate capacitors. Okay, so two parallel plate capacitors are there, 2 microfarad. Along with reading the questions, you should be also doing the diagrams. Joined in series. Combination is connected to battery V. Okay. The values of potential across two capacitors is V1, V2. Right. Energy stored in two capacitors U1, U2. Okay, and they are related as. Okay, so the potential and energy are they are asking. Okay, so first of all, what things are given? Potential are given and capacitance is given, right? So the energy we know U is equal to Q is given, Q's. Okay, so half QV, sorry, half CV square. C is given, right? Sorry, C is given, so half C1 V1 square. U1 is half C1, U2 is half C2 V2 square. All right, so we have C1 and C. So U1 is, if you see, U1 is half into C1 is how much? 2. We don't need to write microfarad here, okay? V1 square. U2 is how much? Half into 3 into V2 square. Okay. So Now we have to find their relation, right? How they are related. Okay. So how are we gonna do that? Okay. If you see the options, if you check the options, it's a bit different. We cannot get the ratio from here. You can check here. See, we cannot get the ratio because see, if I take the ratio even u1 by u2, it will come something like 2 by 3 v1 square v2 square. So this is not what it is asking here. It is asking like relation between v and u, or v and u like the ratios separately. Okay? So we have to do something different. What can we do? Okay, let's think it a bit differently. If I can, okay, if I can get the charges, or suppose, mm, right, okay, yeah, if I can calculate the charge here, because charge is same, right? In series connection, charges are same, so q1 should be equal to q2, correct? So first charge will be c1 v1 is equal to c2 v2, correct? Q is equal to cv. So c1 is 2, v1 is equal to c2 is 3 into v2, correct? So from here, see, we got a ratio v1 by v2 is equal to 3 by 2. So we got one ratio v1 by v2 is equal to 3 by 2. See which one is there? Okay, option 1. In option 1, there is v1 by v2 is equal to 3 by 2, v1 by v2 is equal to 3 by 2. Okay, now how can we check the u1 by u2? u1 by u2 we can check here. See, we have already an equation here. So u1 by u2 is equal to 2 by 3 into v1 by v2 whole square, right? So 3 by 2 whole square. Yeah. So if you check this one, see, this is 2 by 3, this is 3 by 2 whole square. So this will cancel it, this one, and it will become 3 by 2. Correct? Yeah, because 3, 3 square cancel 3, 2, 2 square 2, 3 by 2. So u1 by u2 is also 3 by 2, v1 by v2 is also 3 by 2. So option A should be the right answer. Did you get it? Yeah. See, here we have to do questions fast, and this one actually, if we see, I have done it slowly. Okay, this should not be done the way I did, because I did the experimental method, like first I did something, but from there I didn't get the answer. That's why I had to do another way. But anyway, this question should take 1 minute. Okay, maximum 1 minute, not more than that. All right. And you can see here easily we could solve, because in series connection we have to remember charges are same and we can equate the charges, get a ratio. Okay, because we need the ratio here. So yeah, so whenever there is a question asking about ratios, we have to equate something with each other, only then we can get it right. So this question is done and dusted. Question number 2 is done. It should take to 1 minute, okay, maximum. All right. Okay, let's move to question number 3. Okay, let me erase it. All right. So two large parallel plane sheets shown in the figure have equal but opposite surface charge density plus sigma minus sigma. Point charge Q is placed at points P1, P2, P3, experiences forces F1, F2, F3 respectively. Then, okay. So, what is the question? Correct answer. So we need to find force. Yeah, F1, F2, and F3. Okay, we'll do it. But for that we need, okay. Force formula is what? Force is F is equal to, okay. F is equal to QE, right? Yeah. So if we can find the electric field, so we can easily get the force, because they are asking which one is zero, which one is not. So if we can find electric, which in which place electric field is zero and in which place electric field is not zero, we can find the force over there. So now let's try it. So in the first region, if you see the first region, uh, electric field is what we know. Electric field is sigma by epsilon naught, right? So see, in the first part, here electric field because of this plate is away from this. Okay, sigma by epsilon naught. So away is going to the left, that means minus I. Okay, because of the negative charge, the electric field will be towards the negative charge. So this is plus sigma by epsilon naught. So see, so the electric field is 0 in the first part in P1. So electric field is 0. So F1 must be 0. Got it? Yeah. So F1 is 0. Exactly the same way if we see this one in the P3.3, if you see the electric field is um, towards negative plate for this one, right? So it is sigma by epsilon naught minus I cap, and it is for positive, it is away at this point. Okay, we are calculating at this point, it is towards the negative and away from positive, so they are again opposite in directions, right? This is, it's an I cap because it's towards right, so they are also cancelling each other out. So electric field will be 0 in the third part also, so f3 is 0. Now in the second part, in the part 2, p2.2, at point 2, electric field is for negative plate, it is towards negative plate. For positive, it is away from positive. So they are in the same direction, right? So they will simply add with each other. I kept, right? So 2 sigma by epsilon naught. So it's non-zero. So electric field is non-zero in this part. So that's why F2 will also be non-zero. Okay. So see which option is F1 is 0, F3 is 0, F2 is non-zero. Option 2. Okay. See, it's a bit, don't go with flow. This is 0, this is 0. You will think first, third is 0. Yeah, first, third is 0, second is non 0. No, this is F3 written here. This is F2. Okay. They have mixed it up. But the option 2 is the correct answer. Okay. Again, this question should not take more than 30 seconds if you have done it properly in, like in board exams, because you all already know in board exams this is zero electric field, this is the only one where electric field is not zero, so that's why force will like act the same. So not more than 30 seconds. Okay, so number 3 is gone also. So next question. So two charged metallic spheres having radii R1 and R2 are brought in contact, then separated. Okay, the ratio of final charges Q1 and Q2 on the two spheres respectively will be. Alright, two charged metallic spheres with radii R1 and R2, okay, in contact, then separated. Alright, so final charges. Okay, first of all, when they are brought to contact, what will happen? Like their potential will be equal. Okay, there will be equilibrium, like the charges will flow and they will achieve a potential, like equipotential. Okay, because whenever like we touch two like this thing, what happens is two spheres, what happens is they attain equilibrium, right? So the potential on both the surfaces now then separate means now they have the same potential. Okay, they have the same potential on each of each surfaces. Okay, so V is equal to V. So suppose first surface k q1 by r1 is equal to k q2 by r2, right? So if I take the ratio, it will be q1 by q2 is equal to r1 by r2. All right. So option 4 will be the correct answer. Again, very easy question. So not more than 30 seconds. So option 4. All right. Next, question number 5. Two resistances are there, 100, 200, connected in series with 20 volt. Reading in a 200 ohm voltmeter connected across the 200 ohm resistor. So we just need to find current, right? Because reading, see, okay, oh sorry, voltage is asked. Okay, we need to find the voltage across this one. Okay, so see, this is okay. What is the total current in this? We have to first find the current, right? The total resistance, if you see, it is 300 ohm, right? R equivalent is 300 ohm. V is your 20 volts. Okay, so current is equal to V by R. So that is 20 by 300. 20 by 300. So this is, if you see 2 by 3 is 0.66. Okay, 2 by 30. Let's leave it like this. 1 by 15 ampere. Okay, so 1 by 15 ampere is flowing through this. Okay, and this one is connected here. So 1 by 15 into 200, we will get this one. So 200, because voltage is equal to IR, correct? So 2 by 1 by 15, both the resistances current is same because these are in series connection. So 1 by 15 into resistance is how much? 200. Okay, so how much it will be? 5, this is 3, this is 5, this is 40. So 40 by 3 is the answer. 40 by 3 is not there. Alright, so wait. I may have done a mistake. Wait. Two resistors are connected in series across a 20-volt battery. Okay, alright. The reading in a 200 ohm voltmeter connected across 200 ohm resistance. Okay, it's 20, 300. By 15 into 200. 5, 40, 5, 3, 40 by 3. Voltage across 100 will be what? 1 by 15 into 100, right? This will be 20 by 3. Voltage across 200 will be, what is the mistake? What is the answer key? Question number 5, uh, option 3. Wait, what is it? Question number 5, option 3. No? Yeah, yeah, question. This is book A, right? Yeah, this is book A, question number 5, option 3. Option 3. Answer should be 10. Alright. See, if this is taking too long in the exam, you should leave it, okay? But now we have to solve it. This is an easy question. Why it's okay? 40 by 3 is actually, if I solve it, 1 is 13.33 volts. 13.33 volts. How can we write it as 10 volt? Anyway, we got 13.33. We don't have any other option. So I'll just leave it. Okay. In the exam, if it was in my exam, I would have left it. Okay. All right. Let's move to the next question. The current through a 4 by 3 current through a 4 by 3 ohm external resistance connected to a parallel combination. Okay. 4 by 3 ohm current through 4 by 3 ohm external resistance connected to a parallel combination of two cells. So there is a parallel combination of two cells. Okay. It's like this. Of internal EMF, sorry, internal voltage, sorry, internal resistance. Okay, let me erase this here. There is a bit space here. So, two EMF are in parallel connection, two cells with internal resistance. First one is 1 ohm, this is 2 volt. And next one This is 1 volt and this is 2 ohm, right? Yeah. So external resistance is there also connected to a parallel combination of external resistance is there. This is 4 by 3 ohm. Okay, this is the external resistance, two cells and is okay. The current through this one is asked. Okay, so this one we can do by Kirchhoff's law, right? If you can write some equations here. So current starts from here. Suppose I, okay, and current gets divided here. I1, this is I2, okay, or I minus I1. Sorry, let's take it as I minus I1. So we will get two equations only. I minus I1. Okay. So let's start with this loop. So 2 minus I minus I1. I won't be explaining you the Kirchhoff's law basics. Okay. I hope you know all that. Minus 2 whole into I minus I1. So this is a mistake here. There is 1. This is 2 minus 1 because this is only a voltage term. 2 minus 1 volt minus 2 volt into I minus I1. And then this term is also there. Minus 1 into I minus I1, right? Is equal to 0. Okay. So if I write it properly, 2 minus 1 is 1. Minus this is 2i plus 2i1 minus I plus I1 is equal to 0. Okay. So if I calculate a bit more, it will be minus 3i plus 3i1 plus 1 is equal to 0. So this is equation 1. Okay. Now we can have to take the other loop also. So if I take the other loop, if you see, this is 1. Okay, here. Okay, let me start from here. Okay, let's go from here. So 4 by 3 into I. This is minus 4 by 3 into I. Now the loop is in this direction, but the current I minus I1 is the opposite direction. So we'll take the opposite signs. That means plus 2 volt into I minus I1. Okay, and then this should be current loop is in this direction but current in the opposite. It should have been taken plus, but now I will take minus because of the opposite of it is opposite of the loop. Okay, I hope you understand this because I won't be explaining this one. This is very easy Kirchhoff's law. So 4i plus 6i minus I1 minus 3 is equal to 0. So see, this is taking a lot of time also. So you can do one thing when you suddenly realize this is a Kirchhoff's law question, you can leave it for last. Like after everything is over, you can do that. Okay, after you solve at least 35 questions or something like that. After you realize that yeah, I have given my best now, I will check. Now I will check the ones that I couldn't do. Okay, if you have time left in 1 hour, so you should keep this one for last. Okay, so this one here. If I check minus 4i plus 6i minus 6i1 minus 3 is equal to 0. Okay, so this is 2i minus 6i1 minus 3 is equal to 0. So this is your equation 2. Equation 1 is your equation 2. So just have to solve these two equations, you will get the answer. Okay, so what are the two equations if I write? Tell me. Minus 3i plus 3i1 plus 1 is equal to 0. This is equation 1. Second equation is 2i minus 6i1, 2i minus 6i1 minus 3, 2i minus 6i1 minus 3 is equal to 0. Okay, so we can easily solve it. Let's multiply 2 on the first equation. So it will be minus 6i plus 6i1 plus 2 is equal to 0. Okay, 2i minus 6i1 minus 3 is equal to 0. So these two cancelled out. So minus 4i minus 1 is equal to 0. I is equal to minus 1 by 4. Okay. So if I is this, don't worry, don't be worried about minus. It means just the opposite direction. We should have taken the opposite direction in the question. So current through the 4 by 3 is what? 1 by, what is the answer? 1 by 4. Okay, minus 1 by 4, right? Minus 1 by 4. Alright. Mm, okay. This one is also not in options. Just let me check once. After this much work, if answer doesn't come, it's very disheartening. Everything is alright. What is the problem? I may have done a bit of wrong, like while writing the equations, maybe. No, I think I made some mistakes, so I cannot go back to that mistake. So I will leave this one also. Okay, another question I have to leave. Alright, let's move to the next question then. Metallic wire of uniform area of cross section, resistance R, resistivity rho, power rating P, and V volts. The wire is uniformly stretched to reduce the radius or to half the original radius. The values of resistance, resistivity, power rating are now denoted by R dash, R, rho dash, and P dash respectively. Okay. So see, the wire is stretched to reduce the radius to half its original radius. So the radius is decreasing. A new radius is r by 2, right? So area will be what? Area will be new area by 4 because pi r square, right? Area by 4. If area is decreasing by 4, the length should increase by 4. Okay, that is the thing we know. Yeah? So area is decreasing by 4, length should increase by 4. First of all, by increasing or decreasing the area or length, our resistivity does not change. Okay, resistivity will remain the same. So I think option 1 and 2 are cancelled because resistivity is the property of the material; it doesn't change. So option 3 and 4 we have to check. We can have it from like radius. Okay, so see, um, R is equal to rho L by A, right? So R dash is equal to what? Rho L dash by A dash, right? Now L dash is 4L and A dash is what? A by 4. So this is 16, whole thing. So 16 R. So R dash is equal to 16 R. So option 3 is the correct answer. So this question should take 30 seconds. Okay. Yeah. Easy question. This question also comes as a 2 mark question in your board exams. So yeah, you can easily solve it. You can pause the video and try to solve it yourself also. Then you can check my solution. Okay, next question is um, three magnetic materials are listed below. Okay, so choose the correct order of materials in increasing order of magnetic susceptibility. You do this one. Solve it yourself. Okay, magnetic susceptibility. So how do we do this? So see, susceptibility is negative for diamagnetic, just smaller, like greater than like positive, small positive number for paramagnetic, and greater than one for ferromagnetic. So increasing order means first diamagnetic, then para, then ferro. DAC, right? Option three. Okay. Should take 10 seconds only. It should take 10 seconds. Alright. Next, to infinity long straight parallel conductors carrying currents I1 and I2 are held at a distance d apart in vacuum. Okay. Force F on a length L of one of the conductors due to the other is. So yeah, try. You first try this question, then I will do. To infinitely straight conductors, okay, carrying current I1 and I2, held at a distance d apart in vacuum. Force F on length L of one of the conductors due to the other is. You know this formula. It's a direct formula, right? Mu naught by 2 pi I1 I2 by L. Right? D. So L by D. Okay. So L goes to the other side, that becomes force per length. Yeah. So proportional to L but independent of I1 and no, that's wrong. Proportional to I1 I2 but independent of a length L. Okay. Proportional to I1 I2 L. Yeah. Proportional to L. This is wrong. Force F on a length L. That means I1 I2 into L because see I1 I2 into L is there. So if it had asked force per unit length, then we could have said that it is independent of length because his unit, okay, unit length. But length is given L, so mu naught by 2 pi I1 I2 L by D. Okay, this is the original formula. So option, this is again, this should take 10 seconds only. 10-20 seconds, alright. We should increase the speed. Okay, this one is done. This one. You must have done these questions a lot of times. Circuit shown below, a current 3I enters at A. The semicircular parts ABC and ADC have equal radii R, but resistances 2R and R respectively. The magnetic field at the center of the circular loop ABCD is. Yeah, for you first try, then I will take your time and try. Okay, how to do it? Magnetic field center. Okay, this is 3I. This is okay. Enters A. Semicircular paths ABC and ADC. Okay, this is ABC. This is ADC. Equal radii R. But resistance is 2R, 2R and R respectively. The magnetic field at the center of the circular loop ABCD is. Okay. You see, first of all, this is 3I, right? The radius here is R. This one. This one is also R. What is given? Resistances. Resistance, it doesn't matter. So, so for this wire, what is the okay magnetic field at the center? What is the magnetic field at the center? V center is very easy question. We know the formula is mu naught I by 4 pi r into phi. Okay, phi is an angle made at the center. Phi is in radian. Okay, so this angle is pi. So mu naught I by 4r. Pi got cancelled. Yeah, and here small r. Okay, 4 small r. So this is B1 for the upper part. Lower part is also because they have the same this one, right? 4r. Yeah, and if you see here, okay. So the thing is, the current. Okay, no, 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 my bad. I said the resistance. Yeah, resistance matters here because here current will be divided, right? Current will be divided into two parts. This is 3I current coming, so it will be divided into two parts. This one, this one. So how it will be divided? It depends on the resistance, right? So I is equal to V by R. Yeah, I is equal to V by R. So the V is not mentioned. That means V should be constant here. So this one is 2R. That means the upper part, the current. Okay, okay. So I1, suppose I1 VR1, I2 is equal to V by R2. So I1 by I2 is equal to R2 by R1, correct? R2 by R1. Yeah. So, and total I1 plus I2 is 3, right? So if I add 1, I1 by I2 is equal to, okay, no, no, just let's not complicate things. R2 we have R1, right? R2 is R, R1 is 2R. So R by 2R, this is 1 by 2. So I1, if I cross multiply, 2I1 is equal to I2. Yeah, 2I1 is equal to I2. All right. So boom. Now I1 plus I2 is equal to how much? Total 3I, right? So and I2 is 2I1. So I1 plus 2I1 is equal to 3I. So I1 is equal to 1. I only. 3I1 is equal to 3I. Okay. I1 is equal to I. Yeah. I1 is equal to I. So I2 will be 2I. Right. So according to that, the magnetic field will change. So now the magnetic field will be what? So V1 will be mu naught I by 4R, 4 small r. So this is I only. I1 is I. B2 is I1 is 2I, mu naught I by mu naught 2I by 4R. Right? Yeah. And see, this one is in this direction. So if I use right hand thumb rule, it is going into the plane. And this one going out of the plane. Okay, so we have to just subtract them. So if I subtract them, I will get simply mu naught I by 4R. Right? And okay, if I subtract them, you'll see I'll subtract from the bigger one to the lower one. So B2 minus B1, This is the bigger one. So 2 mu naught I by 4r minus mu naught I by 4r, and the bigger one will have the directions, that is dot. The final answer will be dot. So the answer is mu naught I by 4r dot. Okay, out of the plane. So mu naught I by 4r out of the plane, option A. Okay, easy question again. It should take 1 minute, okay, but not more than one, maximum 1.5 minute. Okay, okay, all right. Okay. So this is, we solved 10 questions today. So we'll be solving 10 questions every day, so that you can have some practice every day, right? So yeah, keep updated with the channel, and please subscribe and all, so that you can have the videos every day. All right. Yeah. Okay. Thank you.